Hi, my name is Ahmed Al-Manhari, and my project is about building two phone chargers where one uses wind and the other uses heat as their power source. So before I start talking about what I built, I want to tell you about the survey that I have conducted. I have asked 50 people 3 questions, and based on their answers I decided what to build for this project. The first question was, what is the thing you hate most about your phone? And as you can see, 60% of the people are suffering from low battery issues, and my project is about building a charger. Coincidence?
I think not!
So we know that a lot of energy goes to charging our phones, which means more carbon emissions due to the increased production of the consumed electricity. The second question was, which one of these activities do you do most? Mine is cooking because I can't afford to buy a car, unlike the majority of the people who I have surveyed. But that's not the important conclusion, which is that people are inactive most of the time. So I knew that the charger that I will build must not be exhausting to turn on. So a crank charger will be a bad idea, for example. The third question was, which of the following phone chargers would you prefer to use? And its purpose was to confirm my conclusion about the second question. And I was right. People don't like crank chargers, but they equally favor wind and heat chargers. So which one of the two did I decide to build? I decided to build both. So I believe my project belongs to category 6, which is build some things. I know this is grammatically incorrect, so please don't take off points for that. To build the heat-powered charger, you will need 3 thermoelectric Peltier generators, solder, soldering iron, phone charging cable, wire stripper, and electrical tape. The thermoelectric Peltier generators can be considered as batteries, with each of them generating 1.5 volts approximately. And therefore, if we connect 3 of them in series, then we will get an equivalent voltage of 4.5 volts, which is still enough to charge the phone. Solder the positive end of the generator to the negative end of the other generator, and do so until the 3 generators are connected in series. Finally, connect the red wire of the equivalent generator to the red wire of the cable, and do the same for the black wires. Now you have finished building your own heat-powered charger. Each generator behaves like a battery when it's heated from one side, and after I place the 3 generators on the top of the oven, the phone starts charging. So how does the generators work? When you heat the metal from one end, the other end is relatively cold, so electrons on the hot end will gain more kinetic energy and starts moving toward the cold end. With the electrons concentrated in the cold end and the protons left in the hot end, we get a small voltage. For heating semiconductors, it's the opposite of heating metals, and the positive end will be in the cold side. And by connecting a lot of metals to semiconductors, as you can see, we will get an electrical circuit where the voltage is added up. So there are 2 ways to obtain more voltage from heat. First one is to increase the temperature difference between the hot end and the cold end, and the other one is by increasing the number of metals and semiconductors used. To build the wind-powered charger, you will need a fan, phone charging cable, and a step-up DC converter that converts an input of 3 volts to an output of 5 volts, which will be used to charge the phone. Yes, it's that simple. Connect the red and the black wires of the fan to the step-up converter. Then connect the USB end of the cable to the step-up converter. And there you go. You have built your own wind-powered phone charger. Told you it's that simple. So I needed wind, but I don't have a car. So here's what I did. So what is the cost of energy that a phone uses annually? Well, it's equal to the cost of energy used by 10 100-watt light bulbs in an hour. So the cost to run a single 100-watt light bulb per day is 28.8 cents. Divide that by 24 to get the hour rate, it's 1.2 cents. And 10 of them, that will be 12 cents. So the cost to run a phone per year is 12 cents. So financially you're not saving anything, but these chargers will help you charge your phone, especially if you're one of those people who suffers from low battery issues. For example, you can attach the wind-powered charger to your bike. For the thermoelectric generators, they have the potential to be beneficial on a global scale. Let's take the UAE or Arizona during the summer as an example. Solar cells' performance in these regions will decrease with the increasing temperature. So what do we need? Heat sinks. And what can we use as heat sinks? Fans or thermoelectric generators, which will use the heat to give us more energy back, increasing the efficiency of the whole process and decreasing the amount of energy lost in the form of heat. So that was my conclusion and suggestion to make things more beneficial, and thank you for watching.